Okay, ready?
Yes, we can start, I think.
Are you in silence mode?
Yes.
Hey, that's all about.
I think we can start.
Yes.
Hello, good afternoon. We will start the role meeting. Welcome.
I do remember, yeah. Okay, so here's a note. Well, if this is new to you, please read the BCPs and the documents shown here. And the one point I want to emphasize is that we want to have a friendly and cooperative and positive behavior in the group. Meeting tips. Please remember to register to that session. If you're remote, you have joined already through Meteco. If you are in the room, join through the on-site version of the tool. And if by any mistake you joined through the full tool, make sure your sound is turned off so that we don't have local echo here. If you're remote, please, and want to speak, make sure you use a headset, otherwise we would get echo as well, most likely. Yeah, presumably you know the agenda already. And the one point I want to emphasize is if you need technical assistance with the tools, here's the URL to go to. Yeah, I don't know. We are taking notes on CodeMD. The link is here on the second line. Please join. Taking notes. We have Michael, Ivan already committed to take notes, but feel free to join and help. Especially if you say something, ask questions, go back into the notes and make sure that your question was correctly understood and you're happy with the way it is represented. We have a chat on Zulip as well. And yes, if you want to edit the minutes, you need to be logged in through the data tracker, and that will serve to log into the minutes as well. That's you.
Thank you. Okay, the agenda for today, we're going to give a working group status. Then we are going to provide some more details in current documents like NSA, Audit Variable, Enrollment Priority, MOPEX, RNFD. Then Pascal will provide the update on DAO projection, which the Shepherd document is in progress. Then Pascal will provide as well the work on 6-law multicast registration. And then we have open floor for further comments. It's okay? Some comments on the agenda? Okay. Next.
Okay, Meet Echo. We have a message on the main display here in front of us that says shut down, yes, no. I don't know how to say no. So if some technician can see that. Would help us.
In here.
Yeah, right here.
We put like no, but
Yeah, I don't know how to put
I
no.
think
I have no control.
Mm.
Is your computer shutting down?
No, not my computer, just this display.
That's the external.
I don't know. Anyway, we can do without it, but just you can. Let's click on this. Anyway.
So maybe, yeah.
No, I don't think this controls that. I don't know.
Okay. About the yellow draft, we are going to provide some more details. And about the blue DAO projections, is going to be discussed today. Yep. And then, so for the milestones, we are a bit delayed with the DAO projection, so we will need to ship it as soon as possible. And then for the yellow ones, we need to put efforts on completing those works too. Next slides. Okay, now more details on document status.
Okay. So we're going through the list of a few drafts that we have in the group, and we don't have the authors here to talk on. So we have an NSA extension. Just to remind everybody, this is a draft that proposes a new objective function and a new metric container extension to carry the set of parents of a node in a DIO, and that allows a node that receives the DIO to know its potential grandparents. And so we had Alvaro's review in March, asking a few questions, providing comments. About 20 of those were noted as major comments. And well, yeah, the authors are still working on them. So please, yeah, we keep bugging them, but we really want to move this forward. We need a revised draft before we can send to ASG. So that's NSA extension that we have in the works.
Okay, for AuDB Ripple, basically this work introduced DIO options, AuDB route request options, route replay, and target options. As well, this work introduced a new multicast address with link local scope, all AuDB Ripple nodes. This draft as well use the same auth operation of P2P Ripple, but they don't collide, for example, because they are running different Ripple instances. So this are the main contribution of this work. Yes. And based on the last comments in the mailing list, there were a discussion from the authors requesting feedback about Ripple instance ID pairing. How can you detect when you have a lot of AuDB Ripples connections? How can you, the intermediate routines, identify the objective functions? So the authors proposed to use a triple origin node, target node, and Ripple instance ID. Okay, they proposed that, but there were not comments on the mailing list, so we believe that this is accepted as it is. Yeah. Then, okay. A new version was published the version 15 was published on September. Basically, this version addressed the ticket 1, the discuss of John Scudder. Basically, the comments were to improve readability. Then address as well, we believe that address ticket 2, then discuss to basically provide comments to improve the protocol. The authors, we believe, have addressed all the comments. They have replied to Ben, but we have not heard back from Ben, of course, because he changed position. So we believe that those tickets as well are addressed. Then we have as well Pascal review. But this one, it's the ticket number 3. There is some comments that you did, Pascal, that still are in the document. They were not fixed in the version 15. So, do you know if the version 15 addressed your comments? Okay. So we will take as an action point. But yes, there are some comments that you did that they were not addressed. They were still the version 15 with these errors. So, then the review by Conrad, it was addressed. and we got comments in the mailing list in October. So the next step will be a new last call when all the issues are closed. This basically the Pascal review.
Michael in the list. Michael?
Yeah.
Michael Richardson. So this document's kind of come and gone for seems like several years to me. I looked to see if some of the authors are on our meeting today, and I don't see them. And so, I mean, there are 4 authors for a reason, is so that we can deal with authors having different amounts of energy and things like this. So I'd really like to see these other authors maybe could get more involved and finish this document and get it out. Otherwise, it's I think very hard for all the reviewers to hold on to review for sometimes years and then figure out what's going on. So I don't know. I think the working group, we should just kind of put a bit of a deadline on this, and if we can't move it forward by January 1st or something, that we should just take it off our list.
Okay, point noted. Yeah.
Thank you, Michael. Yeah, well, Charlie replied that he will work in last weeks and in few weeks, but yes, we need to put a deadline to get this closed. Then for enrollment priority, well, we have these 7 issues open. So I think, Michael, you will work on that when you have time, right? Based on we understood.
Yeah, I'll take it on again for January 1st. Get it out.
Okay.
Yeah.
Thank you very much. Then MOPEX.
Yeah, just introducing for those who are new to the group, Ripple operates in multiple modes, and we have a mode of operation field in the instance that describes the mode of operation, so that nodes know if and how they want to join that instance. And we are running out of the values in that field. So this draft is about extending that field mode of operation, hence the name mode of operation extension. So again, that's a draft that has been sitting there for long, and we want to revive it as soon as we have the first ones out of the door. And we have a ticket and a few discussions on flags that needs to be agreed on.
Thank you. Then fast border router crash detection in Ripple. So this work was adopted by the working group. It's proposed as an extension of Ripple. Introduce the root node fault detection options that is carried in DIOS and DIS. This document as well proposed 2 roles, acceptor and sentinel. Sentinels are the ones that are neighbors of the root and then monitoring the root. And as well, they have introduced a counter, conflict-free replicated counter. Then it was presented in the last interim meeting, and there was a new version published recently, basically with the editor comments. Then the questions here basically were based on the discussion how the sentinels can detect if the root is alive or not. So, for example, what happens when the sentinels don't hear each other? Does the algorithm still detect the crash of the root? Yes. Then what if most of the direct links to the root fall, but the root is in fact alive? Okay, as well here the root take part in the monitoring, so the root knows when the sentinels are fall. And then if it's how the root get back to the status app, basically trigger a new .ac version. Then there are some other questions that they still need to kind of contribution of the working group. For example, where the counter is located, and is for example in the option, and as well, for example, when if the several sentinels have different threshold in order to detect if the root crash, which one do you take into considerations? Well, actually, you take the one that has the lowest threshold, but I think as well have to be explained a bit more into the document. So these are basically the last questions that were presented in the mailing list. And need more of discussion or contributions and reviews. And as well, I think we get the document shepherd. Michael, do you want? Yes, thank you. So Michael is the document shepherd of this document. And probably if all these issues are addressed, we just can move forward with this document. Do you agree? Comments? Okay. What else?
That's it. We're done for this.
Yes. Okay, I think Pascal, now it's your turn.
Try this. Unless you just tell when you want me to fit this in.
So hello, I'm Pascal Thubert, and this is about the route projection draft for REPL. So just to give a sense of positioning, a sense of history, we basically have a main REPL specification, which is an average purpose distance vector protocol, where we save energy by optimizing routes from and to a route as opposed to any to any. And when we want, which because east-west is kind of a rare traffic in usual IoT networks. Now, when we want to optimize device-to-device communications, there are basically two extreme solutions on each side, I would say, of this main specification. The first extreme solution is to go fully into the money world. And this is what the AODV specification does, the one that we just discussed and that Charlie is editing. So this is a completely reactive protocol where a device that wants to speak to another device will flood the network with a route request message, which is effectively transported by REPL. Now, the other complete extreme is when the east-west path between two IoT devices is computed by a central controller, which is more the traffic engineering space. And you would say, hey, why do I need traffic engineering in my sensor network? Well, that's because not all sensor networks are meters. There are effectively cases where big robots or industrial appliances, sensors, actuators, PLCs, need to be routed over wireless. And as it goes, REPL is a fine solution for this. REPL will build a main directly acyclic graph for the devices to reliably talk to the route and through the route to the controller. But then for any particular route between a sensor and a PLC or a PLC and an actuator, that will be the controller that will set up the optimal path with enough redundancy between the two devices. And REPL is a protocol of choice for effectively installing that path. And for those who attend ROW, Reliable and Available Wireless, ROW will be the place where we optimize the energy in using those DAO projected routes. So there is a complement between what we do here, which is allow the controller to set up the traffic engineered path that we call a track, and a row where we'll effectively use that track, but just the subset of the geodag between source and destination that is enough to guarantee the level of reliability that we want for the flow we're talking about. So see AODV as a really mobile ad hoc networking extreme of RAW, and see DAO projection, on the other hand, as the fully controlled traffic engineered side of REPL. And main REPL covering like the overall center of that picture. Press the button and nothing.
Did not work. Okay.
Maybe it's off.
I'll be your button.
None of it. Tac. Oh, no, not better. So
That could
double that. Nice
Okay.
meeting you. Can I?
Because you don't
Anyway,
put the
so
USB.
basically that's exactly what DAO projection is. It's a centralized route computation method whereby a controller, which is kind of hidden behind the root, will set up geodags within a geodag. So typically you will build a main geodag that connects to the root, which has enough redundancy, etc. It's going to be a non-storing mode geodag. Why do we want that? It's because non-storing allows the root to already know a lot of the topology of its network. And what we will do with our projection is extend that knowledge of the topology with sibling information. So the controller can effectively build optimized east-west routes. We build two things. One of them is what we call a segment. A segment is something that complements a geodag. It's a serial set of routers, A to B to C to D, and that allows to connect the dots. So once you start doing this, the first usage that you can have is within the main geodag. You may decide that your source route path now can be loose as opposed to strict. So you know with REPL non-storing mode, you have the situation where you have to put all the hops down the geodag inside every packet, and that might be a long list. When you want to compress that list, you basically want to install the dotted lines, the connection between the dotted lines as storing mode routes inside the non-storing mode geodag, which effectively builds an hybrid solution with the main geodag expressed as non-storing, but the data flowing along storing mode routes which connect the dots in the routing header. So now your routing header can become loose, and it's up to the controller to decide which specific routes will be optimized. Because as you know, the main reason why we are not operating storing mode for most cases is because we don't know that we have enough memory in the devices to store all the non-storing mode, to store all the storing mode routes. Here, it will be the controller, the root, which will know the capabilities of the devices and only install as many routes as a device can actually support. So it will be up to the controller to decide, hey, here are the paths, the source route paths that are used extensively. Let me compress those ones. It's more interesting to save energy within the capabilities of the nodes along those paths. So that's what the segments are. A segment can be connecting the dots in the main geodag or in what we call a track. So a track is this east-west path that is also a REPL geodag that is also installed in non-storing mode, just like the main geodag. And then again, there can be segments to connect the dots. Okay, so the track is a loose structure that basically gives you the skeleton of the geodag and how to go between one node and the next node in that skeleton is using, again, a segment, but this time a segment in that track as opposed to a segment of the main geodag. So you can see the main geodag is just like the track 0. And the optimized path between A and B are geodags as well, just like the main track, the main geodag. Next slide, please. So this is basically representing what we build. I've shown that before. There are basically two ways of installing projected routes. One is storing mode, the other is non-storing mode. In black in the middle, you can see a non-storing mode, a storing mode PDAO. It goes to the egress of the track, of the segment, and it will fly to the ingress of the segment, and the ingress of the segment answers. If you look at it, that's the way DAO works. A storing mode DAO starts at the end of the path and flows towards the root, which is the ingress of that path. Well, same thing, you flow from the end to the beginning of the segment. So it's just a normal PDAO. It's just that instead of being generated by the destination like we do in normal REPL, in this case, it will be injected, really projected by the root into the egress of the segment. And now what we represent in gray on the left is the track itself. And the track itself is a source-routed dotted line thing. And in this track, we have relay A, relay B, and egress E, which are connecting in ingress I's DODAG. So what happens to build it is a single non-storing PDAO that goes to the ingress, and the ingress will reply, because the ingress is the one which will have the full topology of that track. It will not know the segments, but it knows all the relays. So A, B, and egress. And how you go from A to B, well, that could be through another track, which means an underlay inside the underlay. Or it could be through a segment like we do between relay A and egress E. So basically, you can see a track as an underlay that is dynamically installed by REPL in order to shortcut, to do like a wormhole between an ingress and an egress. And it is installed on purpose by the controller, and the amount of redundancy that you can have in this DODAG and the reliability of the links, etc., it's all known from the controller. So the controller, in order to ensure a certain amount of reliability, will provide enough redundancy in the possible path in that DODAG. And then, as I said, RAW will use that dynamically to optimize spectrum and energy. So you see in this slide two main legs. Basically, one is on the north and one is on the south. We call them legs. And then we interconnect the legs with not exactly north-south segment, but east-west, but up-down segments. In RAW, there is the concept of north-south segments, which can be used in either direction. But in REPL, we don't know how to build that because we only build DODAGs. So you see there is always this angle. You're always going slightly to the right. Next slide, please. So draft status, we started the work group last call at 29. For all I know, all the issues are resolved with the latest version, which happens to be 29, and it is my belief that we are ready for publication. Next slide. So just to give a hint of what happened, so during IETF 28, we discussed a number of things that could be improved or clarified in the document. In particular, we needed to clarify that each REPL instance, each track, is effectively its own RIB. And that's why, as you know, we have what we call the RPI, the REPL packet information. In the REPL packet, it's effectively the topology indication, which will tell you which RIB you're talking about. In .NET terms, because I see some .NET members, it is also the .NET path, if you like, that you're talking about. It's signaled by the REPL packet information, which is a hop-by-hop header. Now, there was this long-standing question about how do you avoid loops when you can have topologies within topologies, when you have dotted line tracks that are joined by segments, and then you have neighbors or two hops neighbors. How do you ensure that you don't end up looping? And to ensure that, the DAO projection draft had two methods, and we refined or added text to clarify that at the very beginning of the document. There are two things which must happen. The first thing is kind of classical for those who participate to multi-topology routing efforts in the past. The main thing is the topology, if you can go from topology A to topology B by, say, injecting a packet in an underlay, then you can never go from topology B to topology A again, because you could create such a path that you end up looping. From one topology, you go reverse versus the other topology, and you end up looping. So what you can do with something like that is you can take a packet from the main DODAG, put it in a track, but then it has to go all the way to the destination within that track, or an inner track, which tells you that there must be a partial order, a DODAG of tracks, if you like. There cannot be a loop in the way the tracks are ordered. You can always go from a certain underlay to a lower underlay, but never to an higher underlay, which could take you back. So that's the first thing, having this partial order of underlays. Now, the other thing that we have, because we have different methods, we have the track, we have the segments, we have the neighbors, we have the 2 hops neighbors, is we enforce, and that was the text that Raoul has started long ago, we enforce a strict preference into which type of route you're using. So if you have a track route, a segment route, a 2-hop neighbor, and a 1-hop neighbor, you always favor the 1-hop neighbor. If you don't have a 1-hop neighbor, but you have a 2-hop neighbor, then you will use that. If you don't have that, you have a segment, you always use the segment. If you don't have a segment, the only thing you have is a track route, then you will use the track route. And then again, this is how we ensure that we don't loop. And there was some text which looked opaque to the reader, which really happens when you have this track. So this is this complex path, if you like, between the source and the destination. And 2 segments could cross. So you go from this point to this point, or this point to that point, but in the middle, there is the same node. So you see, which sees a packet with the same RPI information, same topology. Should the route left or down? What segments are you following? And effectively, since the next stop in the loose source route is indicated in the packet, this can actually be resolved. So it's not a real problem. But we clarified how that happens. The last but not least thing that we clarified is the way the multicast DAO works. The multicast DAO is not your usual DAO. It is like a broadcast over the radio medium, whereby a node can say, hey, I'm here. Here are my IP addresses. If you want to talk to me, don't look at your REPL database. Just pass me the packet. I'm your neighbor. Okay, so it's just a way to advertise self as a direct neighbor to the other guys around. Now, the cool thing with DAO projection is we have added the concept of sibling in the DAO. Remember, we did that to provide more topological information to the root. Since we placed our siblings in the DAO, we also have it in the multicast DAO, meaning that when I say, hey, I'm here, I've got a IP address, I'm also saying, here's my list of neighbor. And for the many guys, I mean, you will recognize your next operator or something. I mean, you know the guy which is behind your neighbor. And with this, you can get to those 2-hop guys without a loop. So that's why we have those 4 mechanisms effectively in REPL: the track, the segment, the 2-hop neighbors, and the 1-hop neighbors. The 2-hop neighbors are obtained because we see them as siblings in the multicast DAO. And that's pretty much it. There were some typos, as always, when you push the draft. When I push the draft and I look at the DF, I find, So there was a like main, which went lowercase in some titles. I guess it's still there. I will have to fix it. That's when, or maintenance, that's when I removed the uppercase M in main DODAG because it was written uppercase main all the time. And it seemed that the uppercase was not appropriate, so I removed that. And also, when I pushed some text, I pushed it twice with 28, so I removed the extra copy in the intro with 29. So that's where we are. And that's pretty much it for me.
Okay, thank you very much, Pascal. Yes, we believe that the issues were addressed. And the question is, Raul need to confirm the loop avoidant text?
Yes, and I think I saw Raul's name at some point.
So it's just typing in a chat.
Hello, Raoul.
Raul has just typed that he believes newly
he wants
text
to-
handles the comments. Very good. Raul, come up by yourself.
Thank you, Pascal, for I can see that the new section essentially goes into details about stating a lot of things explicitly for group avoidance. And I've already reviewed section 3.2, and it makes sense to me. Certainly addresses the comments. I'm just trying to check whether it has impact on any other section. More or less, I don't have any outstanding comments as of now. So thank you very much.
Okay, great. Thank you very much, Raul. Okay, so then we finish the Shepherd write-up, and we press the button. Okay, thank you,
So,
Pascal.
Alvaro, sorry, but
More work for you.
more work for you. It's not the thinnest thing we've produced. So, and happy to work with you again.
Yeah.
The next, I'm next, right?
Yes.
You're next as well.
Let me follow myself.
Any other comments in the room about this DAO projection? While I switch slides.
Please, you need to skip a good number of backup slides.
Yeah, I just. share
And
them
so I
separate.
left in that presentation a whole history of drawings that were presented during the elaboration of the protocol, so that if you guys, for some reason, want to explain what DAO projection is, you can dig those slides and get them.
Okay.
Okay,
Come back.
so the other thing I wanted to present to you guys today is work which is happening at 6LO for now, but which impacts Ripple and Roll as well. And what it's doing is extending RFC 9010, which is a Ripple unaware leaf, for different types of addresses. So the first draft that you're probably all aware of is the one that avoids using MLD in an LLM. As you know, MLD is like traditional ND. It's using a lot of multicast. And as you know, multicast is harmful when you want to preserve energy, so, or broadcast really. So the same way that we can avoid broadcasting NSNA messages using 6LoWPAN-ND, we can also get rid of the multicast in MLD, the report thing, by proactively installing the multicast and anycast addresses the same way we install the unicast addresses using 6LoWPAN-ND, so using RFC 8505. So what we are doing here is extending the work that we have with RFC 8505 and RFC 9010 to multicast and anycast address. Now, as if that was not enough, there is a new piece of work where we want to redistribute into Ripple external destinations which are not necessarily hosts, but can also be prefixes. So how can you inject in Ripple a stub prefix? We certainly did not want a Ripple network, or did not expect a Ripple network to be a transit network, but we've always thought that a Ripple network could be connecting stubs. But what we didn't have is a way to install stubs into Ripple by a node which does not support Ripple. So what we can do with hosts, injecting their addresses with 6LoWPAN-ND in a protocol abstract fashion, we didn't have for prefixes. So that's why we are now having this new prefix registration extension that allows a node which it is Ripple unaware to talk to a Ripple router and say, hey, I have this stub prefix. Please inject it in Ripple. Next slide, please. And by the way, we'll be presenting that at 6LO and at SNAC as well, because it kind of solves some SNAC scenarios as well. So now that the 6LoWPAN-ND starts to be an interesting family. So we started with 6775, which was the starting point, and working on it and deploying it, we found it had a number of issues, so we ended up solving them. And 8505 is the second and I would say final version of the address registration mechanism in ND. Then we produced 8928 to secure that, so that gives you something like SAND, but probably better, because SAND is limited in the size of the cryptographic token. At 928 is not. And we provided 8929, which is the first time where an address that is registered through 8505 is effectively redistributed somewhere. In this case, it was redistributed in ND itself. So it's basically a host using 8505 to talk, for instance, to an access point, and asking the access point to do proxy ND for the host. And the proxy can be bridged. That would what happened with Wi-Fi, because the MAC addresses are bridgeable, in which case basically the router would defend, the AP being a router, would defend the address of the stay using the MAC address of the stay. So the packets will be bridged directly to the stay by the access point. Or it could be a routing bridge, in which case on the Ethernet backbone, the router, again acting as access point, would present its own IP address. It would present its own MAC address for the IP address of the stay, meaning that the MAC address of the stay would not be visible on the Ethernet fabric. The cool thing about that is the layer 2 becomes very, very stable. So that's the routing proxy. In that case, you can have devices which are not only bridgeable MACs like Wi-Fi, but also non-bridgeable MACs like 802.15.4. So that's what it was designed for. So that's at 929. And since then, we have redistributed 6OpenND in a number of protocols. So that there is Rift, there is Ripple with 9010. There is a draft for EVPN. I mean, as soon as you have the information that the IP address is there, and with 8505, the host can signal, hey, please route to me, then the router doing any protocol can inject that IP address inside that protocol. But like I said, it was only for IP unicast address. Now, the 6-law multicast registration allows the host to proactively say, hey, I'm listening to this multicast address, please inject it in Ripple as well. Or if you're using Meeple or something else, then it's going to be Meeple or something else. So basically, multicast registration adds Anycast and multicast. Ripple storing mode as a native support of multicast. We added something for non-storing mode, which is basically replication at the root and tunneling to the device. Unicast lookup. I have David asking something.
Oh, yeah. Okay.
Yeah, David?
David, come on.
Yeah. David Lamparter. So I just wanted to note that the Wi-Fi setups, when they are bridgeable, they are not actually mesh networks. So you cannot have a bridgeable Wi-Fi mesh setup. So those are different types of 802.11 operation. So I'm not sure. Okay.
Yeah. Once you reach the router, yes, effectively, if you have a layer 2 mesh, we don't really see it, right? So we just see the MAC address of the destination. If we want, and that's what we do with Ripple, we build the mesh at layer 3, and that's what we call route over. So there is the mesh under, which is what 802.11s would have been doing. And then there is the route over, which is what Ripple would be doing. And we could effectively do Ripple over Wi-Fi if we wanted to, or over 15.4, which is a very classical thing. And then there is this new work I just hinted, which is the prefix registration, and I will come back on that a bit later. Next slide, please. I just don't know how much time do I have. Do I have a lot? I'm short.
You have 10 minutes. 5 minutes.
So multicast registration, as you know, it's being expected by the Wi-SAN Alliance. It's covering their needs. So we move quickly on it, and we get support from Wi-SAN people at the same time. We have beefed up the update RFC 6550 quite a bit. So we explain things like how we use the rover and the lifetime when you get the same information from multiple listeners of the same multicast address. How do you merge the route ownership verifier and which lifetime you pick? We talked about freshness, and as you know, the freshness is what allows you to detect to route when there is movement. So when there is movement, the host indicates in 6LoopND a sequence counter, so you know the freshest location, that's 9010, and the REPL carries that sequence and only retains the route which has the freshest sequence, and that's basically the way many protocols work. And REPL is just designed the same way. When you have multiple listeners listening to the same multicast address, you cannot compare the freshness information from that different sources. But if you know the different DAO come from the same source through different paths, then you can still compare, and that's what we explain. So the rover basically indicates what the source is, and as long as you see different DAO coming from the same source, you can still compare the lifetime, otherwise you can't. The sequence counter, I'm sorry. And we have this consistent uptime option, which is something we want to place in ND messages, array, and others. And we had that open question with 6man, basically. Should we export that option outside of this specification or keep it in there? And Eric Klein at the point, and I've not seen really a definitive answer. So for now, it's still in this document. Basically, the goal here is when you register something to your router, you want to know if the router has rebooted and has lost the state that you have registered to it. And it's true along a REPL path. If your parent reboots, you want to know, so you need to send your DAOs again. Next slide. So probably the most meaningful change that happened is there were 2 bits in the ERO option in ND messages, the DAR message, and the REPL target option message, which would indicate, well, if the bits are 0, then it's a unicast address. If the first bit is on, it's a multicast, second bit is on, it's anycast. And if we do that, we have this value 3, which is kind of unassigned and wasted. But since now we want to register prefixes, why waste this value? So instead of saying it's 2 flags, we turned it into it's a 2-bit field, which we call the P field, as opposed to the A for anycast and M for multicast flags. We turned that into a 2-bit field, so we can use the value 3, and we'll use it in the other spec for prefixes. So now in this P flag that you can find in ERO, in DAR, and in RTO, if it's 0, it's a unicast address. If it's 1, it's a multicast address. If it's 2, it's an anycast address. If it's 3, it's a prefix. Next slide. Oh, by the way, in this particular slide, document, the multicast, we say unassigned, and it's the other document, which is the prefix registration, which really assigns it. Now, this is extra burden for the INA. So if we adopt the document, maybe we could assign everything there and avoid having a IANA registry for just the P field. Next slide.
5 minutes. Let's try to converge.
Okay, so yes, so please go down. Okay, so that's the other draft. As we, yes, I will need the previous slide actually, because that's the intro for it.
Okay.
So this is RFC 9010. And what it allows is me to take the mic. It allows a device that doesn't speak REPL to register through RFC 8505, provided by RFC 8928, an address to a router which is REPL router, and the REPL router will redistribute, will inject that route, that host route, into the REPL domain. Okay, we can do it for host. The protocol is 6LoopND. It is independent of the routing protocol that happens above. We have this for addresses. Next slide, please, Namik. And now what we want to do with the new prefix registration is to do the same thing for external destinations, which happen to be not routes, host routes, but prefix routes, stubs. Next slide. So if you're doing normal REPL, you can always inject prefixes. REPL is not just for host addresses. It is a routing protocol. It's a classical distance vector protocol. Just happens to be anisotropic. But we can only use REPL to advertise prefixes. If we have, next slide, please. If we have a non-REPL device which happens to own a prefix, say it connects to a stub, or it's even a prefix which is inside that device, well, 6LoWPAN-ND does not allow the device to tell the REPL router, so the REPL router can redistribute that. Next slide. So that's pretty much what we are going to add, allowing 8505 to register prefixes. Now, if we register prefixes, the main question is, hey, one of the roles of 6LoWPAN-ND is to ensure that the address is not a duplicate. You have a return code to say, hey, this address already exists in my network. What happens with prefixes? Well, with prefixes, instead of managing exact match, we'll have to have some policies to say, hey, this prefix can be obtained by this guy because it's within a larger aggregation which we own or something like that. So we'll have to have some policies which replace DAD. DAD is an exact match of the full address. Here, when a router wants to autoconf a prefix or claim a prefix, we will have to check that it's allowed to claim that prefix. And there will be policies. But that would eventually allow a device to autoconf a prefix, just like we autoconf addresses. Next slide. How that would work? Well, same thing as for host address, but it would be for a prefix. The device down there would claim a prefix through 6LoWPAN-ND, and the router, the first REPL router, will inject that in REPL. Now, a question that is to be discussed with the group is, should we still use NS with the arrow option in there, or should we call that an RS? Should that be an RS array as opposed to an NSNA, or anything else? Because I'm getting a lot of trouble just because we are using NS for the registration. So if really we need to invent a new message, I mean, that's still possible. Next slide. And as I hinted you, we are extending the P field, so now the value 1, as opposed to be, hey, what is that when there are two flags? Now it really means registration for a prefix. Next slide. And here is basically the flow that you would get with RFC 8928. So you send a host, auto-configures an address or now a prefix. It would send an NS with the arrow. If the rover is a crypto ID, it would be challenged for ownership of that ID, so the crypto happens. And if effectively the host can prove ownership of the rover, then the DNA will be accepted. So the big change is the arrow is now a stub registration, meaning that the target that's being advertised is effectively a prefix, so you have a prefix length in the arrow option. Next slide. And now there are tons of things we could be doing, but I'm short.
Yeah.
So it was mostly to tell you guys that this is happening, and the hope is effectively that we have protocol independence, something which is completely not dependent on REPL, which allows a device to advertise a prefix that REPL will redistribute. And then?
The diagram I want to see, the previous, yeah. So what is the destination of our address of NS that you are replacing with the solicitation?
In this message, it's the router. It's a unicast between the host and the router. So the destination is the link local address of the router.
Okay.
Okay.
Any question when I go home? Alvaro, that's for me?
Hi, Alvaro Rotano, Routing AD. Just for the chairs, can you please track that draft?
Yes.
Just like you're tracking the multicast one, and make sure that there's coordination with 6LoW.
Yeah, we do.
Yes.
Yes, they are family.
Thank you very much, Pascal. Do we have reviewers for this document? No. Do we have reviewers for the document? Someone want to review?
Asking for volunteers to review within the role working group.
Yeah. Okay, maybe we can take to the mailing list.
Okay.
Next slide.
So, any other business?
The next slides will be like the open floor. So from the last meeting, we have an action point for future works, like how do we do management in Ripple? So that is something that we need to start working on. Something to think as well and research on that, on this. Additional comments?
Well, so this is open floor. Any comments from the group, as what we should be doing? As I said at the beginning, we want to ship a few documents that are in our way and have been sitting for a long time, and then we can open up new avenues for work. So as Ines mentioned, we want to address the management issue of Ripple routers. We also, one thing that we've been considering for a while is putting together the Ripple v2 specification. So pruning some stuff that is not used and nobody seems to be interested in, and merging in the various options, various additions, extensions that we've produced over the last 10 years. And so any comments on that? Any other stuff that you think we should not be missing? And no comments. Yeah. Oh.
For those who care, I made the exercise of turning the original Ripple specification 6550 in XML v3. So that was not a small endeavor, but I made it. So if you want to see the original Ripple formatted like XML 12c v3 can do, it's effectively available. The draft is expired, but it's been published. So there is effectively, if in the ROLL library, a Ripple v2, if you like, draft under my name, which is for version 00, the exact copy of the RFC, but in XML to RFC v2, v3.
Right. Thank you for that effort, Pascal. And actually, I want to mention that you already started what should go into Ripple v2, the 6550 bis draft, which we need to revive as well. Ah, okay.
The exact copy of Ripple version 00.
Right. Okay. Anything else from the floor?
Should I raise hand? Okay. It's not about the Ripple protocol. I just want to clarify the terminologies because this group is using the LLN nodes and the 6LoWPAN-ND, they are calling the 6Low nodes. And another RFC by the, I think, Christian Bremen from Germany, he wrote that constraint nodes. So I discussed with him.
Can you speak closer into the mic, please?
So should I repeat again?
I think I got that
in this group or the RPL, so they are calling the nodes like LLN nodes, and in the 6Low group, they are calling the 6Low nodes. And another RFC by the Creston is 7228. They are calling the constraint nodes. So why not we call this whole stack that having these protocols like RPL, 6LoWPAN-ND, 6LoWPAN, like we call the nodes like 6Low, then categorize later into 6LR or 6LBR. So this is just a comment.
Okay. Yeah, thank you for the suggestion that we harmonize notation between the various groups. Jump in. They are not actually quite the same, but we can make an effort in that way.
Yes, the point is 6LN is a logical function. It's not really a physical node. So agree for LLN node, this is very vague because when we started this, we didn't have the 7228, it came after. But for the 6LN thing, that really means a node which can play RFC 8505, right? So it's a logical function. A ripple router is expected to be a 6LN, and it's probably a 6LR as well. But it's a logical function. So doing ripple, doing 6LopenND, these are logical functions in the same node. So it's not really the type of node.
The point is, if 6LN is a constrained node or no? According to
It doesn't
RFC.
have to be. I mean, it's just a node that supports 6LopenND. We want to extend the range of application of 8505 to any device over Ethernet, over whatever you like. They will still be 6LNs because they speak at 505.
Thank you. We've reached the top of the hour. Any last minute comment? Then meeting's adjourned. Thank you very much. And let's carry on. Virtual interim. Okay. Let's plan for that. So we can have more time, devote more time for focused discussions. Okay. Done. Thank you.
Thank you. Thank you very much, Dominic.
Sure, my pleasure.
My pleasure to meet you.
So, okay, let's wait. Does it stay on or do you turn it off? Or, I mean, is the recording ended? We
No, it
can.
stays on, no, it's only recording via the stream.
Okay,
So when
so if we
check
want
the
to say anything confidential, we need to move
yeah,
on.
well, I mean, pretty much recording all the time, it's only when the stream is on.
Mhm.
So that's the only thing I don't really record.